2 weeks ago, you couldn't do it. 2 years ago, you couldn't do it. When was your prime? When was your physical prime?
2016.
People around here talk about your prime, actually, I think.
Oh, yeah?
I hear people say, dude, you work with Tyler Reid? And I'm like, yeah. And they're like, dude, he used to be yoked. Yoked. Was this the time? 2016?
That's probably...
Your physical prime?
Yeah.
Could
Probably.
your hips move back then?
I wasn't as mobile. No.
Oh.
I was actually...
All the bulk kept you from being able to, like, scratch your head and stuff. Must have been hard.
Yeah.
Yeah?
I was a lot more mobile growing up.
And then you got bulky?
Yeah.
Messed everything
I
up.
shrunk. And now I have neither bulk nor mobility. So, getting old.
Do you think they're related? Do you think that bulking stage messed you up at all?
No, I actually think that I'm accustomed to being stronger. And so I do things that I don't have the strength to do.
Is that right?
I think so, yeah.
You've been weak your whole life. You finally bulk and get big for like a couple months.
10 years. Like 10 years.
Oh, you were bulky for 10 years?
Yeah. I mean, it was a process, but yeah.
Wow. Okay. Well, I underestimated the length of time that you were bulking.
Yeah, it wasn't like
that
I
you were
had a
hefty
big
lefty.
meal.
So you did get used to it.
Yeah. I used to be stronger. Now I'm just weak, feeble.
I wouldn't say that you're weak. You're feeble for sure.
Yeah.
He's our sensitive boy.
Oh.
Well, welcome back to the pod.
Yeah, welcome back.
We're actually... Do we even need to tell people that this is...
Nah, I don't think so.
Okay, well, tell them.
But there has been something I've been dying to talk to you about, which for a moment, for a span of like 1 or 2 weeks, it was all the rage. Actually, 2 things happening at once.
Okay.
And we never got to talk. And so it's a little bit past the point of being relevant at all. But, you know, printheads know that you're a big fisherman.
Yeah. Yeah.
So does the words, "we've got weight and fish," mean anything to you?
Yeah. Yeah. So I saw that video.
I bet you did.
You know what's funny?
What?
Like, none of my fisherman friends shared it with me. Like, hey, dude, have you seen this?
Really?
It was a Jed here at work.
Oh, yeah?
Sends me that on Instagram. The day it happened.
Yeah.
He's like, dude, have you seen this?
Yeah.
And I'm like, no, flipping away. I had to watch it. Of course, I watched the thing, and then I like looked for any additional information.
Yeah.
I found out some of the stories online that were circulating, and then within a couple days, there were podcasts covering this, like fishing podcasts, which I told you I listened to.
Oh, I know.
And they brought the tournament director on. Like, they had 2 tournament directors from tournaments these guys fished in.
Oh, wow.
I got the full story. I watched the full weigh-in from start to finish because they live streamed it. And so I got to see the recording of the live stream and totally like saw the fish that came across before them. There were some good bags and the fish were huge.
Uh-huh.
And theirs come through. The fish are clearly shorter.
But heavier?
But heavier.
So
like
is that
heavier.
What caused them to look into it deeper?
Well, see, in
Or
this is something like a casual fisherman or even a non-fisherman just won't understand. But like, and everyone thinks that it was a bass tournament. It was a walleye tournament, which I do want to say.
Oh, that is an important differentiation.
They're different. Bass fishing and walleye.
That sounds very important.
Listen, bass fishing is a conservation effort, right? It's a live weigh-in, live release. So all those fish swim away.
So yeah, that's different.
Walleyes catch and keep. So these tournaments are caught and kept, and they're either donated or the anglers themselves take them home and cook them up or whatever.
Yeah.
And walleye, I think they just do better reproducing and stuff. So that doesn't necessarily harm their numbers, but it's not like a conservation type thing.
Gotcha.
And that's actually what enabled this cheating to happen to begin with.
Right.
Because these were dead fish already.
You can't put fish sticks in a live fish.
They put a fish fillet, frozen fish fillets and weights. For those of you who didn't see this story, they put these 2 anglers were fishing as a team in a championship event. They were like first or second in points going into this event. They needed an outright win to seal the deal. They got the outright win for about 3 seconds unofficially before the tournament director was like, hey, let's have you guys take some pictures with those fish. And as soon as they were done taking pictures, he went down there with a fillet knife and cut one open.
And that's probably not normal. So he suspected something.
He suspected it. And so getting back to the main point, like the casual observer doesn't realize like how tuned in fishermen are to the size of fish. Like I can guess on a bass, a normal size bass, you know, say a pound to about 6 pounds. Really? I can guess probably within 3 ounces. So less than a quarter pound of a fish's weight. And I put this to the test all the time. Me and my buddy Zach, we do this.
Yeah.
But bass are different though, because they can bulk.
They've got like the gullets.
Like you. They can bulk. Yeah, they've got that big gut pouch, you know. So they can get broad and not necessarily correlate to length. And so the guessing is more dynamic with bass. Walleye, it's very like length dependent because they're pretty much straight torpedo shaped almost all the time. And so, yeah, when those fish come through at a certain length, you can pretty much dial in, oh yeah, those are 7 pounders, those are 6 pounders, 6.5, 6 1/4, whatever. And this guy, the tournament director's like, I could tell they were 4.5 pounders. Mm-hmm. And he's like, and the scale bottomed out at like 32 pounds, which would have been a Lake Erie record on 5 fish.
Oh,
right?
On 5 fish, okay.
Yeah, so the scale is like, it didn't actually bottom out, but it clunks straight to 32 pounds.
Yeah.
And like 2 or 3 groups before them, a heavy bag came through and it was like 26 pounds or 28 pounds or something. It was a nice bag. Clearly better than theirs. And so it was like, it was obvious.
I'm just sitting here thinking, for like the last 30 seconds, I'm just thinking in my head, you're giving me a lot more than I bargained for.
Sorry. I obsessed over it. You should have never brought it up.
It was all the rage. And there was 2 cheating scandals happening at one time. The other was the chess cheating scandal, which I was all ingrained in.
Tell me about that.
Well,
I didn't hear about it.
Oh, you didn't? Do you know who Magnus Carlsen is?
No.
He's like world #1 chess champion for the past 10 years. Like, just dominates.
Is he a young guy, old guy? Describe him to me.
He is about our age. Maybe a couple years younger than us.
So neither young nor old.
Yeah. Do you know any famous chess players? I don't know any famous...
Bobby Fischer?
Yeah. Yeah.
Then that's it.
That's it.
That's where
Bobby Fischer was most relevant in the 1970s.
Okay.
So Magnus Carlsen, he's the hottest, you know, around.
Okay. So was he cheating?
No, of course not. It's an American guy named Hans Niemann where he beat Magnus playing black. Black is second to move and it's perceived as having a disadvantage because you're mostly on defense. Mm-hmm. So he outright beat Magnus as black, and Magnus didn't come out and accuse him of cheating, but he kind of insinuated some things.
Which is what you would do as a chess player.
You can't come out and say it. And so one of the things that came out later is like a sign that he thought that something wasn't right with how he's playing was he didn't appear to be playing very hard. Like you can imagine.
How do you look like you're playing hard in chess? Like beads of sweat?
You're sitting there for hours, and are you concentrating?
But you're timed, right?
Yeah, but it's on your moves? It's on the scale of hours. So this isn't blitz chess. This is like classical chess where each side has like hours to their clock.
Speaking of,
so if you were sitting
in the weeds,
yeah. So anyway,
kidding.
That was also all the rage, and it was the same thing where all of these people who were outside of like these core people who know I like chess and like I talked to chess about it was like all these other people like, did you see this? Da, da, da. And it was pretty exciting that people were like.
So how did he cheat?
For a while.
What was
No one knows.
So wait, so then he didn't cheat. Well, if nobody knows how he cheated or what he did to cheat, then he didn't cheat.
Yeah. So with the chess, like at any given time, you can look at the pieces on the board and you can give each player a relative score, and it's compared against chess engines. So chess engines, computer programs, will evaluate the strength of each side.
Okay.
And so as you're watching a game play, you could see like, oh, this guy's got 2 pawns advantage or a half pawn advantage. And you could see if someone's playing better than the chess engine, like consistently move after move after move after move, like quote unquote perfect play, is very, very unlikely. And then they have like all of their games are completely recorded, so they could compare that against past performances, which for him it's very up and down. And he's confirmed to have cheated online before. But when you're there in person, it's like you and I.
So how was this a scandal if there was no like...
So what made it even more of a scandal is they played within the next week, and Magnus he resigned on move number 2. It's like, I'm not going to play against you. You're a cheater.
Wow.
It's a big deal. It's a big deal.
So more Magnus made this a big deal.
Well,
because he wouldn't play him.
He wouldn't play him.
Should have played him.
Yeah, it's a big deal. It was actually a big deal about 6 weeks ago.
It's not funny.
It is funny.
It's not funny because it's really showing how long it's been.
Yeah,
since
I know.
We,
someone told me yesterday the pod's dead. And that actually hurt.
A Jeb?
Yeah, Jeb told me that. It hurt. It hurt.
Well,
but
it's
dead. Back. No, it's back. We're a few days before Thanksgiving. We're fitting one in right before the holiday break, going into the busiest time of the year for us.
Yeah.
Which is part of the reason. We're committed to doing some episodes, so let's jump into it. Last week.
What you got there?
Do you want to jump right into this?
Well, you're just going to keep fiddling with it? Tell us what it is.
I am going to fiddle with it.
Tyler's got this thing in his hands.
Yeah, it's a wishbone. So, I don't know, maybe 2014 was the first time I printed wishbones to bring to Thanksgiving. Because, like Thanksgiving dinner, you bring everyone in, and everyone wants a piece of that sweet, sweet wishbone, Everyone wants the opportunity to make a wish. But there's only one per turkey for now. And...
for now? Like, well, we're going to genetically engineer a turkey with 2 wishbones?
You don't know. I don't want to commit to saying, like, forever there's only going to be 1 wishbone per turkey. Okay. Things change.
Yeah, things change.
So anyway, I started printing wishbones. And now that we've got a metal printer here, I printed this one in stainless steel. So
it looks really nice.
It has been tumbled.
And, to be honest, if folks want a description of how it looks, it's been tumbled so all the sharper edges have been rounded, but it looks like a cast iron part. It's kind of cool. Like the finish on it, to me, that's how I'd describe it, is cast iron.
I think, it kind of has a cast iron or forged look to it. It's little two-tone. So we've shown as printed parts before, and they're very...
You want to cop a look at that? For those of you watching on the YouTubes?
That's going to be the wide angle. Put it in front of your face. There you go.
Ooh.
And that one's not going to autofocus. This one.
Ooh. Hold it still for a second. Let the camera do its thing, dude. Gosh, for someone who knows, you're gonna do the
Maybe I do know. It'll work. So, what that two-tone comes from tumbling it dry, and that creates a powder, and then that powder kind of gets compacted into the surface roughness. So on that surface, you have ups and downs, and the highest ups get shaved off, and then those downs,
it's an average,
the troughs, they kind of fill in because we're doing it dry.
I see. Well, let's use that as a cliffhanger. Let's break that.
I want to challenge
at the end of the episode.
Yeah, so
me and you.
You and me.
And then whoever gets the bigger side, if it breaks.
I don't think it's going to break. Do you think it'll break?
I think it's going to bend. I think it's going to bend, and it's going to take the old wobbler.
I think you'll pull me across the table before it breaks.
Okay, we'll see.
We'll see. But I probably am just going to fiddle with it.
Okay, well, I like it. Let's put it out front here.
Okay, so last week was Form Next.
Yes.
Form Next is like the IMTS of our industry.
Which I'm really jealous that it's not here.
Yeah.
Because, you got a lot of OEMs that are holding.
Yeah, here being the U.S.
Yeah, because there's shows here in the U.S.
Yeah.
Right before. And they're like, oh, yeah, we don't have this and that because it's going to Form Next or whatever.
That is true.
And it's like...
It's the one...
Dadgummit.
It's the one show that everyone from the U.S. sends, their biggest and best parts, displays, booths, personnel, everyone heads to Form Next.
Did you keep track of anything?
Not much, to be honest.
Well, to be honest, again, squared, the best stuff for us starts coming out now, because this is when the media coverage starts catching up with it.
Yeah.
All the things that were released there, now the videos are starting to flood into LinkedIn and YouTube and all that. All the edits are getting out.
I think that's true. There are some people who really try to do like a day 1, day 2, day 3 recap, but they're always kind of rushed. So I don't pay a lot of attention to those. I prefer to watch the media in the following weeks.
Yeah, me too. And maybe that'll be a homework assignment for me. Maybe I'll find 2 or 3 things that it's kind of the cream that rose to the top that really stood out to me. One in particular that I've already seen that I really liked was this story about automation in 3D printing.
Okay.
Have you seen this?
It depends on what you're about to show me.
So basically, this isn't going to be my YouTube of the day, but you can find it on the interwebs if you look hard enough. I've had customers asking for a long time, like, hey, what's automation looking like? Is Stratasys working on any sort of automation? Is there anyone else that's like looking to automate the full processes here? And my answer has been a little vague. Like, I'm sure someone's working on it, but I haven't seen anything yet. Or if there is anything, it's usually not the OEM. It's someone else that has a few machines and they're trying to automate, things like loading and unloading, starting the print jobs with cobots, things like that. Well, Stratasys has done it, or they're doing it. Okay. Now, I
know what you're talking about.
I don't know how great it works at this point, but it is essentially, I think there were 6 Origin 1 systems. Those are the DLP resin systems that Stratasys makes. There were 3 on each side. Now, I don't know if it was 3 or 4 or 2 or whatever, but there were several machines on either side of this little aisleway.
Yeah.
And there was a robot arm that was loading and unloading the systems. And it was doing it all autonomously. And for a production system, which is what the Origin 1 is, that would help with scale.
It does
big
help.
Time.
Yeah, it does help.
Why do you sound skeptical?
Well,
you look and sound skeptical.
Yeah, it's in the details. It's in the details of things. So I don't know a lot about this. I don't even know if they've really talked about it outside of they built it out on the show floor in Formnext. But there were some aspects about that I've seen probably implemented in less stringent ways. A while back we had an episode where we were talking about Ford automating some of their DLP machines, and they had a cobot on like basically a stand, but that had wheels, and it had a vision system. And so that system could go up to any machine and interact with it because it had the vision system, so it didn't have to have like precisely placed things. And if it moved away, like a human could still interact with the machine. Whereas the way these ones were set up, everything was locked into place. That robot arm was on a linear rail, and it was completely in front of all of the machines. So you couldn't have a human come in and interact with that machine. That's part of it. And then those systems are set up to where you could load and unload autonomously, but you can't get the parts off the build plate autonomously, and like the support's broken off autonomously. So I think that was set up to unload parts, send them through a multi-stage post-processing section, which actually that section where the parts disappeared and then came out clean, that's actually where I want to see the most information come out of.
Okay.
Because the robot stuff is interesting, but that automated post-processing was actually, in my mind, a much more approachable and equally important aspect of keeping a lot of parts flowing through these machines. I was talking with someone about this a couple days ago, and he was saying that your actual time interacting with the machine on these is pretty minimal. A lot of your hands-on time is once the parts come out of the machine, removing the supports, cleaning the resin off the parts, curing them, et cetera, et cetera. Actually, loading and unloading is almost no time at all.
So what you're saying is the low-hanging fruit ought to be post-processing. And what's done after it's unloaded.
Yeah. Yeah.
There is one thing that I would like to say that would be useful in the loading and unloading with the machine is if it has a high degree of repeatability, that can contribute to consistency in the builds. Because we know that with those systems where it's like a turn knob to hold the build tray, and they try to do like matched sets if they know that you're swapping out build trays so that you don't have to recalibrate just for swapping build trays. So they try and get those absolutely dialed in terms of exactness and height. So I can imagine with a machine, it helps add to that consistency. It's going to turn that knob to the same torque every time, versus a person.
Right.
They call it gorilla tight. I've heard it called that by Stratasys. It's just like crank that thing down.
Yeah.
It's one gorilla is different than the next.
We do have some torque tools for aspects of that, but not that top handle.
Yeah, not the build tray fastener.
Uh-huh.
So I can see it being useful in that aspect.
I agree with that completely.
I do think the automation of like the support material and things like that would be a heck of a lot easier if you have the same parts coming off every time. Because it's the same with like machining.
Totally.
You're going to do, like if you have, say, a single operation on a part, like those are your favorite parts, right? You load them up, do a single op, and then they pop off.
Right.
But a lot of times in a single op, you have either like the ribbon that you need to clean up or the little, what do they call those the tabs where it'll do a full perimeter cut, but it'll leave tabs so the part doesn't fly out. Is that it?
Yeah, just tabs.
Simple as that.
Yeah.
Someone's got to clean those tabs off.
Right.
And if you have a million of those things coming out, you're just going to have a separate fixture that fits those parts, and it can just do a quick fly cut or a cleanup pass.
Yeah.
I don't see it being too challenging to do the same type of stuff with additive. Do you?
No, it's there. It's there. Implementing automation with additive, implementing automation with any manufacturing is challenging. Like even if you take the simplest task, there's still an integration challenge there. But it's great to see some progress.
Yeah. Well, it's good to have an answer for people who are asking, like, someone's working on it.
My memory I did find one article about this, and my memory is that they teamed up with a company called Thrive Robotics.
To help with that?
To actually build out the integration. Thrive, I think that's, someone's going to fact check me. I think it's Thrive.
Okay.
But,
I'll trust you. For now.
Yeah, for now. Well, I don't know. I do think vision systems are an enabling feature for these types of tools because they get away from needing the precision placement of everything. You know what I mean? Like I've seen robot displays at IMTS of systems where like I could put this down and a microsecond later it's picked it up because it knows exactly. Or there could be a sea of 1,000 of these, and I could toss one, and it would pick up the exact one that
you threw in.
I threw in. Wild stuff, as opposed to something that's very hard coded and relies on,
everything being in an exact location
within thousandths of an inch and staying there, which is tough.
Yeah. I mean the robot welding, same thing. They've got seam tracing now that they can kind of follow along a path, and that stuff's moving along at a fast pace. I still think there's more automation that needs to be done on the software side, like on slicers.
Yeah.
Where they're dumb it down is not the right way to say it, but where it takes less expertise to actually get in there and start pre-processing parts for DLP or metal or these more, I don't want to call them high-end, but they're not entry-level systems.
Yeah.
It takes some tribal knowledge to understand how to make things work.
Totally. I mean, we can, the same way that, your eyes are calibrated to like a fish's weight.
Yeah.
You know, we can look at parts and shapes like these, and depending on the process that we're going to print them through, we know with some degree of certainty how they're going to behave. So it's predictable, but we're not to the point where the software, as far as I'm aware, like this is not something that's really talked about. But as far as I'm aware, most software is not proactively analyzing geometries and making adjustments either in the process or in the geometry itself to compensate for that. But the fact that our eyes can see it and take a guess tells me that there's opportunity there.
Yeah, absolutely. Well, I like FDM's so easy, right? Like there's a million slicers out there for FDM and they all kind of do the same stuff.
More or
for
less,
the most part.
Yeah, more or less.
But support generation, unless it's a very advanced piece of geometry or use case, support creation's pretty good for the most part.
But it also just follows basic rules. You know, if the horizontal is below a certain angle,
fill it
up with support.
Yeah.
But what you don't see automated is surround something with support because I know it's going to move, or that sort of thing. Like something like this,
walls.
Yeah, or something like this, where we printed it upright. My guess is if I took calipers to this is closed in a little bit. Having a tool automatically generate a stringer here to keep it, stable.
Or like heat sinks. Yeah. Something to draw heat away. It knows, hey, this is a really thin cross section. We know we're going to get warpage.
Yeah.
We're going to add a heat sink.
It's achievable, but I really I haven't seen that commercialized yet. As far as I can remember, just here off the top of my head.
Well, I wish I were smarter and could actually do this type of thing.
Yeah, me too. Yeah, me too. There are tools that allow you to assess the shape after the fact, read that in, and then it will do a shape optimization and adjust it. But it's not doing it predictively.
Yeah. That's a step in the right direction.
Oh, totally.
Because they're getting a lot of feedback from that.
Yeah,
right?
Totally. And I say this broadly speaking. I know that Desktop Metal has a tool that may try to do this prior to their binder jetting. Within their binder jetting ecosystem, they have a tool that is supposed to try to look at the heat profile and the behavior of the parts within the furnace and pre-adjust them. But the software wasn't originally developed to do that. And I haven't really talked to anyone about that in years. So perhaps what I'm saying is untrue, but I just don't know how often that's used. I think it's called Life Center is what it's called.
If it's still around.
Yeah, it might be. I'm not sure.
Speaking of preprocessors.
Yeah.
I saw something cool on YouTube.
Okay.
So
I love when you come out of the woodwork with the YouTube.
Well, this is my YouTube of the day.
Oh, okay.
And we're about halfway through. So
are we already?
It's time, yeah.
Okay, yeah. YouTube of the day.
So I was just cruising my my YouTube channel, checking things out, seeing what was out there, and I saw this thumbnail.
Okay.
Of this overhanging. It was a tubular structure.
I saw this thumbnail. I didn't watch the video though.
It looks like something you'd see in Mario, like one of the tubes that he travels through.
Quick question: when I'm browsing YouTube now, our podcast comes up. Does it for you?
It does?
Yeah.
Dude, that's great.
It is.
That's great.
It's a little weird. But
the algorithm.
The algorithm's working kind of because you can see the views and it's like hundreds of views.
Well, I need to pull up my history. Oh gosh. You cannot show. If any camera's picking up my history, please say that you can blur it out or something like that.
The technology doesn't exist for that.
Yeah, it's true. I think there is technology that can unblur things, which is pretty funny.
Oh, yeah?
Okay, here it is. So the channel's called CNC Kitchen.
Okay.
Very popular channel.
CNC
Close to
Kitchen.
500,000 subscribers.
Oh, really?
Lots of subscribers. So
is it mostly 3D printing stuff, or is it mostly other type of CNC tools, or what?
Well, I don't know. Let's just go on and look at their channel right now. Videos.
Kitchen.
Let's see. This is their latest video. What caught me is the thumbnail, and it says no supports needed. And it's got a picture of this tubular structure that goes up vertically, takes a 90-degree turn. So it's printing horizontally, and it's still a tubular structure. And then it turns up 90 degrees again. That's what the thumbnail is. Is that a pretty good description?
Yeah, I think so.
Do you think that'll come through for our audio-only listeners?
Yeah.
So that got me. I mean, it totally worked.
For sure.
It appears that it's a lot of 3D printing, by the way.
Yeah. I see that.
Yeah, it's primarily 3D printing, at least this first page. So it doesn't look like it is. I was thinking maybe it was CNC machining, or maybe he did some
routers or something.
Yeah. Anyway, I want to play the first portion of this video so you can get an idea.
These are some impressions of what could be possible with the next generation of 3D printing slicers. Completely overhanging surfaces without the need for any supports. Printed on a standard machine. I'll tell you why current slicers are dumb, how you can try out the next generation of slicing, and how even you can contribute that they become a reality soon.
Okay, so I saw an image there that looked like the print axis was tilted.
Yeah, so it's not that the print axis actually tilts. So in CNC machining, you're very aware. Basically, what we're doing in additive is like 2.5D machining.
Yeah.
Right. Like we're moving on a planar surface. You're not really moving in X and Y and Z axes at the exact same time.
You're not extruding through Z. Basically, you're extruding, you're moving in X and Y, and then you step down once in Z, and then you extrude. So yeah, 2.5D.
So here's the idea here.
Though quite recently we've seen a couple of really impressive ways of 3D printing parts that have previously been deemed impossible by using really clever slicing approaches. One of them is non-planar conical slicing.
So this is obviously different. We've talked about 4-axis printing in the past. Yeah. We've talked about some companies that have 4-axis printers. And then this obviously is different. 4-axis, we're not talking 4-axis. We're talking 3-axis.
Yeah, so
and he'll get to that.
He said
non-planar.
Non-planar conical.
Yes.
A bunch of weeks ago, I've shown this technique in my Rodbot video, where I visited the University of Applied Science in Winterthur, Switzerland, where they built a 4-axis Prusa printer that can manufacture complex overhangs without the need for support structure. Yet the best thing is that we can use the same slicing approach on a regular 3-axis printer to achieve very similar results. And this isn't just an idea published in a paper, but you can download the Python script necessary and try this out on your own parts and prints. I also uploaded a bunch of sample G-codes and printables for the not so programming savvy.
So that's all I'm going to play of this video, but if you want more information, he's got links to some of the files that he's kind of already tested out. Looks like he's using a Prusa. Great machine. You talked about this before, but one of the obvious limitations if you're moving in 3 axes with a machine like this is you've got a big blocky print head.
Yeah.
So something more pointed would give you more geometry options.
Yeah, for sure. You know, our nozzle is fractions of an inch or, fractions of a millimeter. So it's quite small, but the infrastructure around the tip of the nozzle is huge.
Yeah.
The heating block and the extruder, it's huge. So that really limits your ability to take advantage of this type of slicing. Unless you could somehow do like a long nozzle. I've never seen that done. I'm thinking it's got to be a heat problem, like keeping that hot enough to extrude.
The extruder on our the F-series machines is pretty long, but it goes through that what do you call it, the bellows.
Yeah,
but it's like the hot tip is like that long.
Yeah, so you're saying it's 2 or 3 inches long, but that goes up into the heater block. So then you have the ceramic heat shield, and then I'm talking about the amount.
You just need that overhang, though. Like, all the stuff on the F-Series is up here.
Yeah.
The reason that's so long, though, is so it can go through the bellows without interference. But imagine if the bellows weren't there. You could do something like this.
No, I don't think it is because of the bellows.
We're going to go, me and you are going to have to go take a walk over there after this.
You unscrew, and then you insert it, and then you screw it. It's going into the heater block. So that...
Not on the F-Series.
Oh, not on the F-Series you're talking about. Yeah.
The F-Series is shaped like a hot glue gun.
I was thinking Fortis.
Yeah, Fortis different. Different story on the Fortis.
Well, I still have never seen an extrusion tip reach down more than, fractions of an inch.
I'll show you this one. I think it would open up some options here.
Maybe.
In the event that Stratasys ever had software that took advantage of this conical slicing.
Yeah.
But this interested me because...
What is conical slicing?
I don't know why they call it conical slicing.
It's different than non-planar, like traditional non-planar.
It's very different. Well, but
I don't know what it is.
Well, from what I can understand, it's just the way that unleashes all 3 axes printing at the same time.
Yeah, I'm just trying to understand the difference between non-planar. So we've seen non-planar, like it would go like this. But that's not really what this is doing. I'm just trying to understand what's the conical portion of it. I'm going to have to go back and look into it.
Yeah, I don't really know, but
we'll have to do a follow-up on that.
It makes sense why it's useful, though.
Oh,
right.
I do agree with that.
So
yeah, I agree it's useful.
You eliminate the use of some support in some geometries, but what I like about it is not necessarily even just that you can do these crazy overhangs. I like the idea of being able to change the direction of the grain in a single print.
Okay.
Does that make sense? So I don't know how this Python script works. I haven't attempted to use this yet, but it may be something I need to look into because I think most of the improvements in FDM that we're going to see that are non-material related are going to be in software. In my opinion, that's at this point, that to me seems like the only thing that makes FDM machines better.
Yeah, probably. Probably.
It's a 3-axis CNC machine that's spitting out hot material. It's like, I'm not saying that I don't want to make that sound.
Adding rotational axes would help. Adding a...
Yeah, but this gives you a way to not even have to add the rotational axes.
Kind of, but this plus rotational axes would be awesome. So having a hardware plus software solution there.
But this is one of those software limitations where if Stratasys decided tomorrow, hey, we've been working on developing this for 5 years for our users, we're going to release it today. They could, in theory, release this for use on an F-Series machine.
Probably true.
This would be, in my opinion, if I owned an F-Series machine, this would be huge.
Yeah, I agree with that.
I would be stoked.
Yeah, I agree with that. But I think that there is still room to improve hardware too, is all I'm saying.
But advancements in the software are going to force them to create advancements in hardware, right? The shapes of these blocks, these printing blocks are going to change.
Yeah,
if you can take advantage of this and it's worthwhile.
Well, the great thing is that software can be updated on a daily basis. I mean, minute by minute, it could be updating itself potentially. It could, but hardware improvements are few and far between. If we're talking about the F series and the Fortis series, Fortis platform has remained unchanged for a decade plus.
It was ahead of its time.
Yeah, it's just stable in what it's doing, and the F series platform is now 7 years old, 6 years old, maybe. I don't know.
Still feels fresh to me.
I'm losing track of time. It feels fresh.
Yeah.
But what I'm saying is that just like with cars, the chassis remain from year to year to year to year. But
in the case of a Nissan Frontier, 16 years. Nissan
Well,
Titan,
you
right around the
can't-
same.
you can't improve beyond perfection. Yeah.
I used to have a Frontier, and I'll tell you right now, it wasn't perfection. It was decent, though. It was a good little truck.
Did you actually end up selling that?
Yeah, sold it. I'm so mad, too. And this is a total side blurb, but Jeb here sold a Toyota Tacoma. Like, apples to apples, they were the same truck.
Yeah.
Mine was actually better. We are both the type of fool that has a two-wheel drive truck in Utah.
I had
northern
as well.
Utah. They work, and
they get around 5.
Around here, people think it's 4-wheel drive or nothing. But like I've had, I think like 5 2-wheel drive pickups here.
I did get stuck overnight in a parking lot once. But that's
you
a whole other
stayed
story.
overnight in the truck.
I did venture out.
Oh my gosh!
I left the
You
truck.
went to the 7-Eleven to get like a hot cocoa or something.
I went to Village Inn downtown.
Oh my gosh!
And I ended up
for a warm slice of pie.
Well, I ended up meeting some people there, and they let me stay with them at their hotel.
Oh my gosh, that is so weird. Anyway, back to the other sidetrack that we were already on.
Yeah.
Jeb was able to sell his Toyota Tacoma 2-wheel drive. No additional features. It had sun-faded paint. It was a hunk of junk.
What else was wrong with it?
It didn't have a working radio. There was a lot.
I thought he listened to our pod.
Yeah, he used a Bluetooth speaker in his truck.
Oh, yeah. We actually are not on the radio, so that makes perfect sense.
Yeah. Yeah, he tuned it to AM. No, but he sold his for $8,000.
Okay.
So that was like, at the time, I was like, dude, I've got a 2-wheel drive Frontier. It's a mid-sized truck, same deal.
Yeah,
Except mine had a locking...
You started seeing dollar signs?
Yeah, mine had a locking rear differential, though.
And a custom welded exhaust.
That's right. TIG welded, by the way. It was actually a good exhaust.
Yeah.
If anyone ever put my truck up on a rack, they'd be like, who would do this?
Oh, for sure.
Frontier.
I mean,
had like some pie cuts in it and everything.
Yeah, your Frontier was well maintained. Well maintained.
Probably too maintained. Yeah, so someone was really lucky because they got it for $6,500.
That's basically the same price.
I had offers for like 72 that I was like, yeah, I'm going to hold out because my friend got 8 G's for his.
Yeah.
They're not the same truck, evidently, to people. His was rusting out. Mine was like in pretty decent shape.
It's because it's a Tacoma, man.
Good night.
You've never seen, go to Instagram, search overlanding, and you'll never see a Frontier.
Yeah, but no one ever overlands in a 2-wheel drive Tacoma.
Yeah, they do.
Not a 2-wheel drive.
Yeah, they do.
No way.
Yeah, they do.
Okay, whatever. So, I don't know what got us on that topic, but it's just funny how there's this intrinsic value in certain names of things, even though mechanically they're both big V6s, like 4-liter V6s. They're
basically the same thing. Basically the same thing.
Different labels.
But a different buyer. Different buyer.
Right? Which, they should be the same buyer. It's going for the same stuff. Anyway, can we figure out a way to segue this back to 3D printing?
Yeah.
Okay, go.
How many 3D printed jigs did you use when you were welding that exhaust?
None. Because it was a one-off. If I had to
Even
make
for cuts or anything?
I did actually 3D print the so the bends.
Yeah.
I wanted to figure out the pie cuts, right?
Yeah.
So I printed off some. I've seen these online before. I think people sell them as FDM printed things. Some people have injection molded versions, but you can click these pie cuts together, and people use them to build custom exhausts, custom headers, whatever. And I did have
like a planning tool.
Yeah, I printed like 10 or 15 of these things.
I didn't know that.
Yeah, and I used it to kind of like route the exhaust around things so I could figure out, I'll use my... Because I did buy a kit with like a bunch of pre-bends, like mandrel bends and stuff in them. I only had the pie cut version just on like the turn down tip. But
I'm going to be doing some welding soon. Went and got my argon tank filled up. Or this was the
huge,
argon
way oversized argon tank.
It's huge. Yeah, it's huge. I'm going to put it to use.
I finally fired up my torch. I have an oxyacetylene torch that I picked up in kind of a cool deal.
Yeah.
I've had for years.
Yeah.
Finally swapped out the tanks thanks to a buddy of mine.
And? What'd you do?
I was afraid I was going to blow blow my garage up because I've never used the hose. There could be a leak, all kinds of stuff. I cut a little piece of steel, but I rested it on a piece of wood. And my friend was there, luckily. I started cutting it in the wood. I could smell the wood starting on fire. I'm like, oh my gosh. But yeah, that's it. I'll probably be using it more for like preheating metal for welding.
They are handy. I actually, you know what? I say that they're handy, but I never use mine.
Do you have a plasma cutter?
Yeah.
That's probably
But I never use that either.
Oh, can I have it?
No. I am gonna be using my torch though shortly. I gotta cut up some beams, some 5/8
thick stuff,
5/8 inch thick beams. Mama. Yeah,
that's gonna make some slag. You better wear some good shoes.
Oh, good call.
And like jeans, good call. Or even an apron or something. So
I'll wrap my boots in old denim.
Denim is very flammable. You need Kevlar.
This guy's feet are on fire.
Anyway,
I do have like one of those tan welding blankets.
Yeah.
Yeah.
Wrap yourself in it.
Toga style.
Oh my gosh, please no. I'm not going to talk about this video that I saw on the interwebs, but it was funny. It was about welding safety.
Oh.
And it was a slow pan. I am going to talk about it now. I'm already started. It was a guy... it was a welding safety video, and he's down there welding. He's like MIG welding, and the camera's in front of him, and it slowly starts to do like a 360 pan around. Yeah. And about halfway through, you realize the guy's got no clothes on behind all his welding gear.
I do think so. I've got these 8-inch by 8-inch I-beams.
Mm-hmm.
I think they're W sections because they're not perfect I-beams. They actually have a taper on the inside.
Yeah.
And they're thick. They're like 58 pounds per foot. And I may end up doing some angle cuts, and I'll probably print something just to even mark that angle cut. Because if you're trying to mark a 45 in that deep webbing, how do you even do it? I couldn't.
It's real hard telling.
So I'll probably print a template just to like draw a chalk line.
Dude, have you seen the guys that make like anvils out of those old like W beams?
I can picture it.
And like railroad ties.
I have seen railroad ties. Yeah,
pretty cool.
That is pretty cool. Cutting through a railroad tie seems like it would be pretty challenging.
I could do it.
I'd probably try to do
my
it with
oxyacetylene setup for sure.
You would try to cut it with the torch?
No.
I would try to put an abrasive disc on like a concrete saw. That's how I would tackle it.
I'll tell you this. Any saw I've ever used with an abrasive disc, I can bog it down on like angle iron.
Yeah, but it will eventually cut through it. I'd rather use something like that than my bandsaw.
I think you'd have better luck with a 4.5-inch angle grinder because you got the RPMs on your side. Yeah, you can just sit there and...
Yeah, but you'd have to like go all around. I don't know. How big is a railroad track? Like that big? Like 5 inches tall? Yeah, I don't know.
Well, let's get back on track. Now we're just talking about personal projects.
We're just talking about welding for the past 15 minutes.
The other day.
Yeah.
And I want you to tell the listeners how that went.
It went pretty well. We did it with Velo 3D. A guy named Sid joined me. He used to work at an automotive company as an additive engineer. And we talked about using M300 tool steel, printed M300 tool steel from the Velo system.
Why didn't you make that out of the M300?
Well, that's a good question. One, I didn't want to change the material.
Oh, just lazy.
Yeah.
You didn't want to do a little vacuum job.
I barely have time to run the print.
I'm just playing with you,
but
dude.
I could have changed the material in about, 30 minutes to an hour on this machine.
On the exact metal.
On the exact metal machine. And M300 actually prints pretty dirty. It creates a lot of soot.
Oh, okay.
And so for that reason, I try not to print it unless it calls for it.
316 is a much cleaner material.
Much cleaner, yeah. Oh, I should tell you though, I originally processed these parts in 17.4.
Okay.
And apparently 17.4 parameters are much higher power, or it's
what
higher.
Did you do to the machine?
I don't know. It's higher energy density. Let's just say that. So I can log in through the browser and I can see a live feed of the machine, and I look at it and I was like, I didn't know that was a color camera. It was glowing. It was glowing.
The part was glowing.
Glowing.
Through the powder?
After it did a layer, you could still see it glowing.
Just the cross section?
Yeah.
Oh my gosh.
It was glowing like yellow.
Do you know some metals are transparent when they glow?
No.
Yeah.
Really? Like
yeah.
glass?
There's a header material that they use in Formula One, or at least during some era of Formula One. They're always changing things, but there's a header material that turns transparent.
That's pretty cool.
When it's glowing.
Yeah, that's cool.
Sorry. Total sidetrack.
So, what was I talking about?
You're talking about how hot the parameters are.
Oh, yeah. So, I messed up. This is 316L. And
whoa. So, that failed. It was a failed print.
I failed that. I stopped it as soon as I could.
Okay.
It's not normal for these to be glowing red hot.
So, I mean, what do you think that's due to? Just too small of a cross section?
Well, it was higher energy density than the material was designed to handle. So, like when you're coming up with laser parameters, you're looking at laser. So,
were the parameters off for that?
I processed it with parameters for 17.4 stainless, but we had 316L stainless in the machine.
Oh, you didn't mention that.
Yes, I did. Roll the clip.
You're talking about how hot the parameters are.
Oh, yeah, so I messed up. This is 316L. This is 316L. This is 316L.
Okay, this makes more sense now. Sorry.
Yeah, it makes more sense.
Sorry if I'm off track.
But why was I talking about that?
Because you were telling us how you failed with the old parameters.
Okay.
You're telling us about your webinar.
Oh, the webinar.
Sorry, that's right. It's me that's getting us off track.
You asked me why I didn't print these in MP3.
Yeah, this is an episode of tangents, for sure.
So the webinar was really talking about conformal cooling channels in tooling, high-pressure die-cast tooling, but conformal cooling channels. And Sid and I dove into the research, which I still have access to all the research papers through my University of Utah login from 13 years ago, which is the best gift ever. Just keeps on giving. I'm still paying for school, so that only seems fair.
Yeah.
But I learned a lot about conformal cooling, and definitely the research.
Tell us what that is.
Well, say like you were going to injection mold this part.
Okay.
So you would have a core and a cavity, a mold, right? And since it's flat on one side, you could get channels very consistently close to that side.
With a traditional method. You have a block of material, you're going to drill holes into it, and they could run right above the channel, and it's going to be consistent distance. But on this side, because it dips down, if you drilled a hole, it would either have to be close to there, but not close to this side. It won't be a consistent distance from the surface of the model.
Yeah, that's right. So you would want a channel that goes up and dips around.
Which you would not be able to do with traditional...
just drilled holes. So... but if you print a channel, it could dip it. And just times that by whatever factor for a lot more elaborate parts, especially high pressure die cast parts where the temperatures of the metals that you're injecting are in the upwards of 750 degrees Fahrenheit. The pressures that you're injecting are immense. The speeds are immense. And you're doing it tens of thousands, if not hundreds of thousands of times. So anything that you can do to improve like the how homogeneous the cooling is across the part, how consistent it is, and also how quick it is, will improve. The economics are crazy. Like if you can shave seconds off your cycle time, then your cost per part goes down immensely. And conformal cooling allows you to do that. The science is there, the research is there. It's just creating the tools has always been pretty challenging.
Do you have any parts like from that webinar on hand?
No. No, I didn't print any parts.
I'd really like to see one of those.
I didn't print any parts for it, but I have a good PowerPoint.
Can you provide any stills?
Yeah, I have a PowerPoint.
Our producer?
Yeah, I can.
Eliante pulling up, feeling like Harry Belafonte. Look at my racks, feel like Serena went from the back. Swing, pull like Jim, waves on swim, anorak Tims with the tech. Butterfly doors on the Tesla, I just spent shit on gas.
Well, to everyone out there, happy Thanksgiving.
Happy Thanksgiving.
Hopefully this goes okay. Should I
Don't
my
close
laptop?
this.
I will not close my laptop. Don't pull the plug, literally.
We can put this down.
Yes.
Are you ready?
Maybe we can get the mic on this. Okay, you ready?
that was a very...
You want to do it point up?
Well, wait. Isn't that how you do it?
I don't know. Okay.
Okay. Are you ready?
Are you just gonna
3,
just pull straight away? Or are you gonna lever? Oh, okay.
3, 2, 1. Keep going.
Let's take a look at it.
Oh.
There's some major deformation there.
Your side is deformed, mine is not. More or less. Can you see that? Let's see. Okay.
That's pretty tough.
That's Tate's side, that's my side. That's definitely plastic deformation, so we yielded it.
Let me get this it's oh. Don't be a wuss, dude. Pull.
I'm trying, I don't got good grip.
Okay.
My hands are too moisturized.
Let me hand this over.
Double grip it.
It's too strong. I can't.
You're not going to break it.
I can't do it.
I mean, it's failed.
But
it's not broken.
Impressive. That's 3D printed, y'all. That is a little wishbone that the likes of me and Tyler could not break.
And
2 horsepower.
We could strengthen that through heat treatment.
I'm out of breath. That's pretty cool.
Yeah.
So
That's
neither
cool.
of us are lucky, or what's the deal there?
Neither one of us are having our wishes granted this year.
I think if we just keep working on it and bending it back and forth.
We could fatigue it.
Yeah.
If I could get it back. I'd have to probably get it
Tyler's keyboard hands. Let me.
Dude, I've got mechanic hands at this point.
Does he? Look at those ginger little things.
What are you talking about?
Just kidding, mine are too. But you're having a lot of trouble.
Well, my hands literally...
This is a good moment to fade out. Anyway.
That's pretty close. That's pretty close.
Happy Thanksgiving. He's not.
Yeah.
What's the matter?
Nothing. This is fun. Hey, wow. You just did that in seconds.
Yeah. You know, different hands.
You've got more padding on your hands.
Yeah. All right. Well, thanks for listening. I've got a homework assignment. I will find some more cool stuff from Formnext to tell people about. Yeah. And what are you going to do? Just go eat a big old turkey?
Rest and try to heal my body and enjoy
Get those
Thanksgiving.
Get those hips moving again?
Yeah.
Okay.
Okay.
Cool.
Take
See ya.
it easy.